All right, so there are different models of the atom, and you have to know the name that pertains to which model and the description. I've given this to you in the chapter handout on the front page. Okay, so we've got Dalton's model, which has to do with Dalton's atomic theory. Make sure you know all 5 of the points. You're going to want to put that on a note card or make yourself a Quizlet. And then we've got Thompson's model, and these all follow in like sequential order. So order is important, okay? Thompson's model was also known as the plum pudding model. The video that you're going to watch in class also calls it the chocolate chip cookie model, which I think sounds much better. Basically, the plum pudding model is this sort of like dense, positive sphere, sort of like a really heavy blueberry muffin, okay? And then the blueberries that are interspersed throughout the muffin are your negatively charged electrons. Thompson had a young scientist in his lab named Ernest Rutherford who did an experiment called the gold foil experiment, where he took radioactive particles called alpha particles, which were positively charged, and he shot them at the gold foil. And if the plum pudding model was correct, then all of those alpha particles should have gone straight through the foil and hit a detector on the other side, but they didn't. Once in a while, they were deflected because they were hitting this really small region inside the atom known as the nucleus. And the nucleus is positively charged, and like charges repel. So that's why once in a while the alpha particles hit the nucleus and then they were deflected in the opposite direction. This is also stated for you in your handout down here, so you're going to read this and know it. Okay, so this led to something called the current nuclear theory of the atom, which says that most of the atom is empty space. We have protons and neutrons inside the nucleus, which you learned about in a previous class, and the electrons are outside the nucleus. This is on the next page at the top. You have to know this table, 4.1. You don't have to know the mass in kilograms of protons, neutrons, and electrons, but you do need to know that the mass of a proton is about 1 AMU, which stands for atomic mass unit. You need to know that a neutron has a mass of 1 AMU, and an electron essentially has a mass of 0. Make sure you know the charges of protons, which is +1. The charge on a neutron is 0, and the charge on an electron is -1.